Imagine your new app goes viral. A million people click your link at the exact same time. If you only have one server handling that traffic, it is going to crash, and you lose all those customers. Here is how AWS Elastic Load Balancing prevents that exact disaster. An elastic load balancer, or ELB, is exactly what it sounds like. It automatically distributes incoming internet traffic across multiple targets, like your EC2 servers, without you having to manage every connection yourself. Think of a load balancer like a host at a busy restaurant. Instead of letting 100 people rush through the front door and crowd around a single table, the host stands at the entrance. They look across the room and send each new group to the next open table. One guest goes here, the next goes there, and everything stays balanced. No single waiter gets overwhelmed, and everyone gets served faster. That is what ELB does for your application. Users never connect directly to your servers. They connect to the load balancer, and it quietly spreads requests across all the servers behind it, keeping the workload even and predictable. So why does this matter so much? The short answer is high availability and fault tolerance. First, ELB gives your users a single point of contact. They only ever see one URL. Behind that simple address could be 2 servers or 200 servers, possibly across multiple locations. The load balancer hides that complexity, which makes your architecture cleaner and easier to change over time. Second, ELB constantly checks whether your servers are healthy. These are called health checks. Every few seconds, the load balancer asks each server a simple question. Are you still alive, and can you respond correctly? Healthy servers answer back. If one server crashes, freezes, or starts returning errors, it fails the health check. The moment that happens, the load balancer stops sending traffic to that server. No waiting, no manual intervention. All new users are instantly routed to the healthy servers instead. From the user's point of view, nothing happened. Your app stays online even while part of your system is broken. This is a core idea in cloud architecture. Failure is normal, and your system should handle it automatically. Exam tip. If an AWS certification question asks how to handle sudden traffic spikes, improve availability, or decouple your application components, elastic load balancing is almost always part of the answer. Now, let's look at how this fits into a real AWS setup. In AWS, a load balancer lives inside your virtual private cloud, or VPC, and acts as the front door to your application. Traffic from the internet hits the load balancer first. From there, the load balancer forwards requests to EC2 instances running in private subnets. These instances are usually spread across multiple availability zones. The load balancer spans all of them and deals traffic out evenly like a deck of cards, so no single zone or server becomes a bottleneck. AWS gives you 3 main types of load balancers. Application load balancers are used for standard web traffic like HTTP and HTTPS. Network load balancers are built for extremely fast, high-volume traffic using protocols like TCP, often seen in gaming or financial systems. Gateway load balancers are used to route traffic through security appliances, such as firewalls. Each type exists for a reason, but the core idea is always the same. One front door, many backends, and automatic traffic distribution. A load balancer is fantastic at spreading traffic, but what happens if every server is busy at the same time and you simply need more capacity? That is where auto-scaling groups come in. Click the video on the screen to see how load balancers and auto-scaling work together. And I'll see you there.